We are going to be solving a ODE, ordinary differential equation using Euler's method. When doing a ODE using Euler's method, we are given a step size. In this case, is our h, which is equals 0.4, and an initial value condition, which is y parenthesis 1 equals 2, and our function, which is y prime equals 2x minus ay minus 2x. In this problem, we are asked to do our problem with two steps, using two step sizes of with the Euler's method. We are already given our ith term, so that's our base. So when I equals 0, so it's when x, we are already given it here in our parentheses of y, so that's gonna be 1. After equal sign, that's gonna be the value of our y's. That's why we already have a 2. And when doing Euler's method, it's very simple to find our x ith term in all of however long the step sizes you are asked to do. So in this case, our initial value for x is 1. So when doing the first step, we're just gonna be adding the step size, which in this case is 0.4. So it's gonna be 1.4 here, and then on our second step size, we're just gonna be adding 1.4 to our step size, which is 0.4. So it's gonna be 1.8 over here. This is our formula, which is y1 equals y0, or y0 in this case is 2. It's over here. And then plus h, which is our step size, and it's 0.4, times the function of f, which in this case is going to be our 2x minus ay minus 2x. So in this case, we're going to be already solving this by plugging in our numbers. So we had first in our formula a y0, so our y0 is 2, it's going to be 2, and then plus our step size 0.4 times our function, which in this case is 2 over here, and then the value of x, 1, 2 times 1 minus 8 here, and then our value of our y is going to be 2, so we plug in the 2 minus 2, because that's what it's given in the function, and then we have an x, so here the value of our x is going to be 1, so it's going to be looking like this, minus 2 times 1. Once we solve this side, it's going to be looking plus 2 minus 16 minus 2. These two will cancel out, leaving only our 16, our negative 16. That is wrong. Let me just put the negative sign right there. And we're going to be doing this final step, which is our 2 plus 0.4 times negative 16, which is going to be our y1. It's going to be over here, and it's our negative 4.4. Then, since this is our first step that we did, we already knew that the number 1 was going to be 1.4. And now we know that y1 is negative 4.4. Now we do our second and last and final step, and it's the same formula. Instead of here being y0, it's going to be now y1, which we just solved. And here r is going to be plus h, just how it was in the beginning. And here our x, it's going to be xi plus h, which we had already established. It was the 1 plus the step size, which is just 1.4. So that's how it's going to be looking every time the formula had an x. The function had an x, I'm sorry. So in this case, it was a 2 times an x, so it was going to be a 1.4 minus 8. Here it was going to be a y. We're already in the second step, so here it's going to be y1, which is a negative 4.4, minus 2. And then we had here an x, and here, and the x is now going to be 1.4 because we added the step size. And after we multiply this, it's going to be looking 2.8 plus 35.2 minus 2.8. Once we add and subtract that, it's going to be looking 35.2 times 0.4 plus negative 4.4, which is 9.68. And that's how our final table is going to be looking. Here, as you can see, our x, it was the initial value that was given, the 1, and then we just added the steps as here, 1.4 plus 1.8. And then here our y, it's the initial value that was given, the 2, and then we found our y1, which was negative 4.4 if you remember, and then our y2 now, it's our 9.68. Thank you so much.